Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Anisa Nawaz from Department of Physics. This is our lecture number 6 from chapter number 1, Measurements. In the previous lecture we have discussed in detail about significant figures, rules of finding significant figures, precision and accuracy. In this lecture we will discuss about uncertainties, types of uncertainties, indicating uncertainties in final calculations, and some examples related to calculate uncertainties in the final result. Before proceeding to our lecture, let's discuss about errors. We will take a quick review of errors. So what is an error? Basically, it is the doubt that exists about the result of any measurements, or we can say that it is basically the difference between measured value and the true value of the thing being measured. Okay, so we are having two main types of errors. First one, systematic error, and second one, random error. Systematic error can be categorized as instrumental error and personal error. Instrumental error, which arise from the errors due to imperfect design or calibration of the measuring instrument. Zero error may also be cause of this instrumental error, and personal error, it is due to the inexperience of the person. It is due to individual's bias, lack of proper setting, or individual's carelessness. And one important point is that these errors are always in one direction. It means that either they are giving us a result which is more than the actual result all the time, or it is giving a result that is less than the actual result all the times. So it is always in one direction. It is either positive or negative. Okay, random error. Those errors which occur irregularly and hence are random with respect to sign and size. It means that these errors occur irregularly. They may be greater than the actual value, or they may be less than that of actual value. So they are not in one direction. They could be greater or less than that of actual value. And another type of error may be least count error. What is least count error? Least count is basically the smallest value that can be measured by the measuring instrument. It is called its least count, and we can only calculate the value up to least count. If we are having less resolution of the instrument, then what will happen? We cannot measure value more accurately. So it will create an error in the measurement. Okay, so now let's discuss about uncertainties. What are uncertainties basically? Uncertainty can be defined as, it means the range of possible values in any measurement within which the true value of the measurement lies. The range of possible values, it means that we are taking different measurements and they are lying within a specific range. That range gives us uncertainty. Or we can define uncertainty as a non-negative parameter characterizing the dispersion of the values attributed to a measured quantity. It means that those calculations which we are doing, they are dispersed within a specific range. That will give us uncertainty. And uncertainty can be written in the format measurement is equal to best estimate plus minus uncertainty. For example, a measurement of 5.07 plus minus 0.02 grams. If we are writing the measurement in this form, estimated value plus minus uncertainty, it means that the value lies between 5.07 plus 0.02 grams and 5.07 minus 0.02 grams. This is the interval within which the values are lying. So all the measurements which we are doing, they must lie within the range of 5.09 grams and 5.05 grams. So this is basically the interval which is telling us about the uncertainty. Okay, so we are having three types of uncertainties: absolute uncertainty, fractional uncertainty, and relative or percentage uncertainty. Absolute uncertainty can also be said as precision or least count, that is giving us absolute uncertainty. Fractional uncertainty, that is absolute uncertainty divided by actual value, and percentage uncertainty is simply fractional uncertainty multiplied by 100. We will discuss that in detail. Okay, so let's say we are making a measurement which is recorded as A plus minus delta A. So what is A over here? A is giving us the true value, the value which we have actually calculated, that was the actual value. And what is this delta A? This is giving us the uncertainty. Okay, so we can say that this delta E over here is giving us absolute uncertainty, which is represented by the symbol delta. So delta A is absolute uncertainty in the true value of A. Fractional uncertainty, it is equal to delta A divided by A, which means fractional uncertainty, which means absolute uncertainty divided by true value. And percentage uncertainty, it is represented by epsilon, which is equal to absolute uncertainty divided by true value multiplied by 100%. So these are three different types of uncertainties. For example, if we are recording a mass which is 3.3 plus minus 0.2 kilograms. So in this measurement, what is there? Absolute uncertainty represented by delta M. It is equal to 0.2 kilogram. This is also the least count or precision of this calculation. So 0.2 over here, which is given, is absolute uncertainty. If we want to calculate fractional uncertainty from this measurement, what we have to do? We have to divide this absolute uncertainty with the actual value, which is 3.3. So 0.2 divided by 3.3 will give us 0.06. And fractional uncertainty is having no units. Okay, it is without any unit. Percentage uncertainty, which is equal to epsilon, it is equal to 0.2 divided by 3.3 multiplied by 100%. We are putting the value in the formula of delta A divided by A multiplied by 100%. So we will be having this value 0.06 multiplied by 100%, which is giving us 6.06%. So percentage uncertainty is 6.06%. So which is rounded off as 6.1%. So we can say that the calculated value 3.3 plus minus 0.2 kilogram, this is equal to 3.3 kilogram plus minus 6.1%. We are interconverting absolute uncertainty into percentage uncertainty. We are just using the formula least count or absolute uncertainty divided by actual value multiplied by 100, and we are converting these values. We were provided with this value 3.3 plus minus 0.2 kilogram absolute uncertainty, and we have calculated same value in percentage uncertainty. Okay, so if we have to calculate absolute uncertainty from percentage uncertainty, then what we have to do? If we are provided with percentage uncertainty and we want to calculate absolute uncertainty, then what we have to do? Absolute uncertainty will be simply obtained by multiplying these given values and dividing it with 100, because percent sign means 1 by 100. So we can simply write it as 3.3 multiplied by 6.1 divided by 100, that will give us 0.2 kilogram. So this value 0.2 kilogram is basically 6.1% of the actual value 3.3 kilogram. So 0.2 is basically 6.1% of 3.3 kilogram. So we have converted this percentage uncertainty into absolute uncertainty. We will get this value 3.3 kilogram plus minus 6.1% is equal to 3.3 plus minus 0.2 kilogram. So what we have done over here, we have converted percentage uncertainty into absolute uncertainty. So if absolute uncertainty is provided, we can convert it into percentage uncertainty, and if percentage uncertainty is provided, we can convert it into absolute uncertainty. Okay, so where we are using these types of uncertainty, if we are making the calculations, so where we are using these? So absolute uncertainty, keep this in mind that absolute uncertainty is used in the questions of addition and subtraction. In the questions of addition and subtraction, we are always using absolute uncertainty, simply the least count which is provided with the value. And fractional or percentage uncertainties are used in the questions of division and multiplication. This is important point to note, that in division and multiplication we use fractional or percentage uncertainties, and in addition and subtraction we use absolute uncertainties. Okay, if we have to indicate uncertainty in calculation, then what we have to do? What is uncertainty? Basically, a numeric measure of confidence in a measurement or result is known as uncertainty. So error was simply the doubt, it was simply the difference between actual and measured value. But what is uncertainty? It is measure of confidence in a measurement, that the measurement which we are taking, how much confident we are about that measurement, that will be known as uncertainty. And lower uncertainty means greater confidence. So what is happening? If uncertainty is less, percentage uncertainty is less, we will be having more accuracy. Okay, so if we want to indicate uncertainty in sum or difference, then what we have to do? In addition, we have already discussed this thing, that absolute uncertainties are added. In addition, absolute uncertainties are added. And in subtraction, absolute uncertainties are added. Keep this in mind, that we are never ever going to subtract, multiply or divide the uncertainties. Uncertainties are always added in all the cases. Okay, so if we suppose that we are having two physical quantities A and B, and which these physical quantities were measured as, let A is equal to A plus minus delta A, where A is true value and delta A is absolute uncertainty in A. B was calculated as B is equal to B plus minus delta B. B is true value of B and delta B is basically telling us about the uncertainty in B. And result which we are doing over here, result can be written in the form Z is equal to Z plus minus delta Z. So Z is final result and delta Z is uncertainty in the final result. Okay, so if we are particularly talking about sum, if we are using addition questions, then how we are going to do that? Generally, if we want to discuss that, let we are having Z is any number which is equal to A plus B. We are going to add these two quantities A and B, and we are getting the result which is equal to Z, where measured quantities are A plus minus delta A true value, delta A absolute uncertainty. B plus minus delta B is true value, delta B is absolute uncertainty. And we are going to put these values in equation number 1. What we will get? Z will become Z plus minus delta Z, A will become A plus minus delta A, and B will become B plus minus delta B. So what we are going to do over here? As it is the question of addition, so we will add absolute uncertainties over here and we will add actual values with each other. Okay, so we will add true values with each other and we will add uncertainties with each other. So what will be the result? That result will be A plus B, addition of actual values, plus minus addition of absolute uncertainties. So final result will be A plus B plus minus delta A plus delta B. Okay, if we are talking about uncertainty in difference, same procedure will be followed. We are having a result which is Z. Let Z is equal to A minus B, where measured quantities are A plus minus delta A and B plus minus delta B. So we are putting these values in equation number 2. We will get again Z will become Z plus minus delta Z, A will become A plus minus delta A with different sign, B plus minus delta B. Okay, so over here what we have to do? We have to combine true values and we have to combine the uncertainties. So you can see over here we have to subtract the true values. We will subtract B from A, but uncertainties are always added. I told you this thing before, that uncertainties can never be subtracted, multiplied or divided. Uncertainties are always added. Okay, so we can write it as A minus B plus minus delta A plus delta B. Uncertainties are added even in the questions of difference. So we are subtracting true values and we are adding their absolute uncertainties. Okay, let's check out example that will make the concept more clear. That is example 1.2, page number 15, thickness of pipe. What is the statement provided? If d1 plus minus delta d1, d1 is actual value and delta d1 is absolute uncertainty, that is equal to 101.41 plus minus 0.05 millimeters, represents the internal diameter of the metal pipe, and d2 plus minus delta d2, actual value plus minus uncertainty. This is equal to 102.79 plus minus 0.05 millimeter. It represents the external diameter of the metal pipe. Then find the thickness of the metal part of the pipe including uncertainty in it. What we have to do, we are provided with external diameter and internal diameter, and we have to find out the thickness with uncertainty. Okay, if both the diameters are having uncertainties in provided with them, so obviously the final result will be having uncertainty in it. Okay, so if we are going to check the figure, we are having this pipe which is having internal diameter d1 and external diameter d2. So how we are going to solve this question? We have to find out the thickness of this metal pipe. We will subtract d1 from d2. If we are going to subtract d1 from d2, so we will get these two values, these two thicknesses. Okay, but we need just one thickness, so in the end we have to divide the result with 2. So we will subtract d1 from d2 and then divide the answer by 2. Okay, so again following the same format, we are having given data which is internal diameter provided, external diameter provided, required is thickness of the pipe. Okay, so what about solution? To find out thickness of the pipe, we would subtract the internal diameter from the external diameter. However, we will add its fractional uncertainty. Okay, we have already discussed this thing that if we are going to do the questions of addition or subtraction, then we have to add their uncertainties. Check this out. D is equal to d2 plus minus delta d2 minus d1 plus minus delta d1. We are going to subtract the actual values and we are going to add their uncertainties. How? Check it out. We are putting the values in equation 1. We get d is equal to d2 minus d1 plus minus delta d1 plus delta d2. We are having actual values which are provided, d2 and d1. We will subtract these two values and we will add their uncertainties. So what will happen over here? We can write the answer in the format which is represented by equation 2, 1.38 plus minus 0.01 millimeters. Okay, 1.38 plus minus 0.01 millimeter. You can see over here that the actual value and uncertainty, they are having same number of digits after the decimal. So same number of decimal places are there. You have to keep this in mind that we should keep same number of decimal places. Okay, since the difference in radius is required for thickness, hence dividing value and uncertainty in equation 2 by 2. So as I have already told this thing that we will first find out the difference in diameters and then we will divide it by 2. So what we will get, thickness is equal to diameter divided by 2, which is equal to 1.38 by 2 plus minus 0.10 by 2. So what will be there? T is equal to 0.69 plus minus 0.05 millimeters. So you can do these calculations yourself. If there is any change, you can find that out. Rounding off may be different in some cases, but that doesn't matter. Okay, so we are having assignment 1.2. A physicist calculated the wall width of half brick thickness. The brick is laid in a flat position lengthwise called stretcher position as 13.6 plus minus 0.1 centimeter. Actual value plus minus uncertainty. Add one brick thickness. Okay, the brick is placed in flat position lengthwise orthogonal to wall called header position as 23.6 plus minus 0.1 centimeter. We are having brick thicknesses which is provided as 13.6 plus minus 0.1 centimeter and 23.6 plus minus 0.1 centimeter. We have to calculate the difference in width of walls with uncertainty in it. So first what you will do, you will write down the given data, then you will write down the required value, then you will start the solution. You will simply subtract these two values. You just have to subtract these two values, subtract the actual values and add their uncertainties. You will get the final result. Okay. So if we have to indicate uncertainty in product or quotient, if we are using multiplication or division questions, then what we have to do, percentage uncertainties of measured values are added. Over here we are not using absolute uncertainties, rather first we will find out percentage uncertainties and then we will add the values. Okay, so if we are having product or quotient, suppose two physical quantities A and B are measured as, again same thing, A is equal to A plus minus delta A and B is equal to B plus minus delta B. Result can be written in the form Z is equal to Z plus minus delta Z. Okay. So uncertainty in product, what will happen, we have product, so we will write it as, let Z, which is final result, it is equal to product of physical quantity A and B, where measured quantities are A plus minus delta A and B plus minus delta B. We are going to put these values in equation number 3. We will get Z plus minus delta Z is equal to, A will become A plus minus delta A and B will become B plus minus delta B. Okay, so we have to convert absolute uncertainties into percentage uncertainties, because we have already discussed this thing that in the questions of product and quotient, in the questions of multiplication and division, first we have to find out percentage uncertainties and then we will add those uncertainties. We cannot directly add absolute uncertainties, rather we will first find out percentage uncertainties and then we will add those uncertainties. Okay, so if we are having delta A and delta B as absolute uncertainties, then we will find out delta A percent, delta B percent. We will convert these uncertainties into percentage uncertainties and we will add, we will multiply A with B and then we will add their percentage uncertainty. So our result will become A into B plus minus percentage uncertainty in A plus percentage uncertainty is in B. So percentage uncertainties, whether they are absolute uncertainty or percentage uncertainties, they are always added. Okay, so what will happen, Z plus minus delta Z is equal to AB plus minus delta A plus delta B percent. So if we are doing this, in the end what we have to do, we have to convert it back to absolute uncertainty. We will find out absolute uncertainty in final result. So the question will, the answer will become Z plus minus delta Z, which is equal to AB plus minus delta Z. Okay, so same rules will be followed for uncertainty in quotient, uncertainty in division question, just the difference will be that multiplication sign will become equal to division sign. So let Z is equal to A divided by B, where measured quantities are A plus minus delta A and B plus minus delta B. By putting these values in equation 4, that will become Z plus minus delta Z, which is equal to A plus minus delta A divided by B plus minus delta B. So above equation, Z is equal to A divided by B will become A plus minus delta A divided by B plus minus delta B. So converting absolute uncertainties into percentage uncertainties, we will get Z plus minus delta Z is equal to A plus minus delta A percent divided by B plus minus delta B percent. Okay, so we will divide these two true values and we will add their percentage uncertainties. Keep this in mind, we are always going to add their percentage uncertainties. So what will be there? A divided by B plus minus delta A percent plus delta B percent. So values are divided and their percentage uncertainties are added. These are very simple questions. Once you will practice these questions, you will understand the concept very clearly, but you have to practice it on your registers or notebooks. Okay, so what will happen over here? Z plus minus delta Z, that is equal to A divided by B plus minus delta A plus delta B percent. These are general values. So you have to apply these general values into calculations. So in the end, last step will be we have to convert it back to absolute uncertainty. Z plus minus delta Z is equal to A divided by B plus minus absolute uncertainty in the final result. Okay. Let's check out an example related to this. Example 1.3, page number 16. We have to calculate area of the room. What is the given statement? The length and width of a rectangular room are measured to be L is equal to L plus delta L, which is equal to 4.050 plus minus 0.005 meters. Okay, make one correction over here. In your book, page number 16, the values which are given in the statement are different than that. They have given 3.955 and 3.050, but in the answer, in the calculation, they have used these values. So make this correction in the statement, in the given statement. Length is equal to 4.050 plus minus 0.005 meters, and width is equal to W plus minus delta W, which is equal to 2.955 plus minus 0.005 meters. Okay, we have to calculate the area of the room and its uncertainty. So what is there? Given data is length and width, and we have to calculate the area. So we will use the formula of area, which is equal to length multiplied by width. So it is the question of multiplication. So let's check out how we are going to solve it. According to the format, first we will write down the given data. Length is given and width is given. We will write down length and width in this format: true value plus minus uncertainty, absolute uncertainty. Required is area, A plus minus delta A, and uncertainty in area as well. That's why we are writing it as A plus minus delta A. In solution, we can say for the product, percentage uncertainties are added. We already know this thing, that if we are solving the product questions, we will first find out the percentage uncertainties and then we will add those percentage uncertainties. So length and width in percentage uncertainties can be calculated as, we know that length is having this value 4.050 plus minus 0.005, and we know that formula of percentage uncertainty is equal to absolute uncertainty divided by true value multiplied by 100. Okay, so we can write it as actual value 4.050 meters plus minus percentage uncertainty will be absolute uncertainty divided by actual value multiplied by 100%. So we will get 4.050 meters plus minus 0.12%. This is equation number 1. We have calculated percentage uncertainty in length. Okay, so we are now calculating percentage uncertainty in width. Again, we will use the given value of width 2.955, and we will calculate percentage uncertainty again by using the formula absolute uncertainty divided by actual value multiplied by 100. We will get the equation 2.955 meters plus minus 0.17%. So we know that area is the product of length and width. We can write it as A is equal to L multiplied by W. By using equation 1 and 2, we are now having value of L and W. We can put these values: 4.050 meters plus minus 0.12% multiplied by 2.955 meters plus minus 0.17%. Again, using the same rule, we will multiply the true values and we will add their percentage uncertainties. We will multiply true values and we will add their percentage uncertainties. We will get this result: 11.967 meters square plus minus 0.29%. And our last step was converting it back to fractional uncertainty or absolute uncertainty. We are having A is equal to 11.967, which is the actual value, and we are going to convert it back to absolute uncertainty. We will simply multiply percentage uncertainty with actual value and divide it with 100. We will multiply percentage with actual value and divide it with 100. We will get absolute uncertainty. So our result will be 11.967 plus minus 0.034. But keep this in mind that most of the times we keep our uncertainty limited to one significant figure. Okay, we keep it up to one significant figure, but most of the times what we do in your book, this rule is not being followed, but most of the times we have to round it off up to one significant figure. So we can write it as 11.97 plus minus 0.03. Okay, and why we have rounded this actual value 11.967? Because another rule, another important point to note is that we have to keep equal decimal places in actual value and in absolute uncertainty. That's why we have rounded it off in this situation like this, that 11.97 plus minus 0.03 meters square, that is the area with its absolute uncertainty. That is our result. Okay, so you are having another assignment 1.3. the voltage V plus minus delta V is measured at 7.3 volts plus minus 0.1 volts, and current I plus minus delta I is measured as 2.73 amperes plus 0.05 amperes. Calculate the resistance by using Ohm's law as R is equal to V over I. This is the question of quotient, question of division. First you will find out, you will write down the given data and required, and in solution you will find out percentage uncertainty in V, you will find out percentage uncertainty in I, you will divide actual values and you will add their percentage uncertainties, and in the end what you will do, you will convert it back to the absolute uncertainty. You have to do it yourself. Okay, so that's very simple question. If you will try it, you will get it. If you're having any problem, you can ask me. Okay, so last thing, if we are going to indicate uncertainty in power questions, then what we will do? If we are having power factor, then how we are going to indicate uncertainty? So percentage uncertainty is multiplied by power. Over here we will use percentage uncertainty because you know this thing that power is basically the question of multiplication. Like if we are having 2 square, which means 2 multiplied by 2, so we will use percentage uncertainty in this type of question. And what we will do, percentage uncertainty is multiplied by power. We will check out general rule for that, and then we will discuss an example related to this that will make the concept more clear. Let z is equal to a raised to power n, where measured value of a is a plus minus delta a. Z is the answer, a is the measured value, or n is its power. Okay, so if we are putting values in above equation, equation number 4, we will get z plus minus z plus minus delta z, which is equal to a plus minus delta a whole raised to power n. We are just putting the value of z and a in the above equation. So converting absolute uncertainties into percentage uncertainty, we will get z plus minus delta z is equal to a plus minus delta a percent. We are converting absolute uncertainty into percentage uncertainty whole raised to power n. And according to power rule, we have to multiply percentage uncertainty with the power. So what we will get, a raised to power n plus minus n multiplied by percentage uncertainty in a. So we can write it as z plus minus delta z is equal to a raised to power n plus minus n delta a percent. And in the last step, again we have to convert it back to absolute uncertainty to get an exact numeric value. So we can write it as z plus minus delta z, which is equal to a raised to power n plus minus delta z. Okay, let's discuss an example related to this. Example 1.4, page number 17 of your book, which is related to ball drop. Okay, the statement is a ball drops from rest from an unknown height h. The time t it takes for the ball to hit the ground is measured to be t plus minus delta t is equal to 1.3 plus minus 0.2 seconds. Actual time 1.3 is given, uncertainty, absolute uncertainty 0.2 is given. The height is related to this time by the equation h is equal to half gt square, where g is 9.81 meter per second square. Formula is given. formula of height, you can see over here two parameters are used, g and t square. Assume that the value for g carries no uncertainty. G is having no uncertainty, so no need to calculate uncertainty for that, and calculate the height h including its uncertainty. So what is happening? Uncertainty will be in t. Uncertainty in t is given and power factor is used, so we will use percentage uncertainty over here. Okay, so how we are going to solve this? First of all, we will write down the given data. Value of t is given, we will write it down. Value of g is given, acceleration due to gravity, we will write it down. A required value is height h, which is equal to h plus minus delta h. Its solution is for the power, percentage uncertainties are multiplied with power. So first of all, we will find out percentage uncertainty. The percentage uncertainty in time t can be calculated as, by the given value we will calculate the percentage uncertainty. Because we are having absolute uncertainty, we will divide this absolute uncertainty with actual value and multiply it with 100. Okay, so how we are going to write it? As 1.3 second, that is actual value, plus minus absolute uncertainty divided by actual value multiplied by 100%. So we will get 1.3 second plus minus 15.4%. We have converted absolute uncertainty into percentage uncertainty. Equation 1, first step is done. We have converted absolute uncertainty into percentage uncertainty. Okay, since the height h is given by the equation h is equal to half gt square, what we will do, we will simply put the values over here with uncertainty in t. Half into 9.81 meter per second square, 1.3 second plus minus 15.4% whole square. We are just putting the values in the equation. Okay, value of g and value of t with square. As we know that this power will be applied on true value and it will be multiplied with percentage uncertainty, so we can write it in this way. H is equal to half into 9.81 meter per second square into 1.69 second, that is the result of 1.3 square, plus minus 2 multiplied by 15.4%. We have multiplied the power with percentage uncertainty, so we will get the result 8.30 meters plus minus 30.8%. Okay, so this is basically the calculation of percentage uncertainty in height, and we know that in the last step we will convert it back to the absolute uncertainty. How? We will use the formula actual value plus minus actual value multiplied by percentage divided by 100, that will be 8.3 plus minus 2.6. okay, so that is the result in height. Assignment 1.4, the radius of sphere r is measured with vernier calipers as r plus minus delta r, which is equal to 2.25 plus minus 0.01 centimeter. Calculate the volume of the sphere. Okay, over here what we have to do, we have to calculate the volume of the sphere, and we know that formula for volume is equal to 4 by 3 pi r cube. 4 by 3 pi is constant, r, value of r is given, its uncertainty is given. What we will do, we will first write down the given data, then required value, and in calculation we will write down, first we will calculate the percentage uncertainty in radius. We will multiply percentage uncertainty of radius with power 3, and then we will put these values in the actual formula, and in the end we will again convert it back into absolute uncertainty. You have to do it yourself. Okay, so the key points which we have discussed over here, to make it simple, we have discussed that absolute uncertainties that are simply the precision or least count. So absolute uncertainties are indicating the precision in given measurement. Okay, but fractional uncertainty, formula for that is absolute uncertainty over actual value. Formula for percentage uncertainty is equal to absolute uncertainty over actual value multiplied by 100%. So absolute uncertainty is telling us about the precision and percentage uncertainty is telling us about the accuracy. Okay, so if percentage uncertainty is less, more accuracy is there, so more accurate result is there. Okay, so absolute uncertainty is basically equal to least count, and we know that if least count is smaller, then more precise value is there. Also, uncertainties are always added. Whether we are doing the questions of addition, subtraction, multiplication or division, we always has to add the uncertainties. In the questions of addition and subtraction, we will simply add their absolute uncertainties. We will add the actual values and we will add their absolute uncertainties, nothing else. In questions of multiplication and division, we will first find out percentage uncertainties of the given values, and then we will add those percentage uncertainties, and in the end we will convert it back into absolute uncertainties. In the power question, percentage uncertainty, we will first find out the percentage uncertainty in the power factor, and then we will multiply that percentage uncertainty with power. Okay, so I would like to end my lecture with this quote: "Nothing in life is to be feared, it is only to be understood. Now is the time to understand more so that we may fear less." Okay, so it's everything which is present around us, everything which is existing, that is to be understood, not to be feared. Okay, so you can understand whatever you want to, just concentrate on that, and what you will do, you will fear less, you will learn more. Okay, that was all for today's lecture. Thank you so much.